Demonstration problem. Shuford accelerates uniformly from rest to 6 meters per second in 5 seconds in a straight line. How far does he travel in this time? Need 3. From rest gives us the initial velocity is 0 to 6 meters per second. This gives us the final velocity. We check that off. In 5 seconds. This gives us the time. Fourth is what? What's being asked for? How far does he travel in this time? This is asking for the displacement. Fifth, not known, is the equation. The thing that's missing is the acceleration. The equation that will work is the acceleration not known equation. This is the equation that will have all the 3 things that we're given, and we'll have the thing that we're looking for. We write our 3 givens, we write the equation, we substitute in, and we get that the displacement is 0 plus 6 meters per second over 2 times 5 seconds, or 15 meters. Demonstration problem 1. Bedrick accelerates uniformly. This means that the acceleration is constant. Since acceleration is a vector, that means that the magnitude is constant and the direction is constant. From rest to a final velocity of 34 meters per second in 4 seconds along a straight road. A, what is his average velocity? B, how far did he go in this time? We need 3 things. The givens are the initial velocity is 0. We check that off. The final velocity is 34 meters per second. Time is 4 seconds. What are we looking for? Part A, what is the average velocity? Part B, how far did he go, or what is the displacement? We put a question mark under the displacement. That means that the equation that will work is the fifth not known, or the acceleration not known equation. Equation for part A. Average velocity for constant acceleration is the initial velocity plus the final velocity divided by 2. Here that is 0 plus 34 meters per second divided by 2, or 17 meters per second. Part B. How far did he go? The displacement is the average velocity times the time, where we just found that the average velocity is 17 meters per second times the time of 4 seconds. He went 68 meters. Demonstration problem 3. Cuthbert slows to a stop along a straight road with an acceleration of -4 feet per second per second. If his initial velocity was 40 feet per second, how far did he go before stopping? We will use the need 3, fourth is what, fifth not known process to find the correct equation. There are 5 symbols needed for uniformly accelerated motion as before. The displacement s, the time t, the initial velocity v sub I, final velocity v sub f, and the acceleration a. The givens are final velocity is 0. He came to a stop. The acceleration is -4. That should be feet per second. The initial velocity is 40 feet per second. The unknown is the displacement is what? The fifth not known, or the equation that will work in this case, is the time not known equation. We write that down. Final velocity squared is the initial velocity squared plus twice the acceleration times the displacement. We substitute in, we solve, and we get the displacement was a positive 200